It's remarkably what the word suggests. It's literally a river in the sky, but it's a river of water vapor pushed along by the wind, unlike a terrestrial river, which is liquid, moved by gravity. Uh, and it's much larger than a terrestrial river in terms of its spatial extent because water vapor is much less dense than liquid. So an average AR is about 500 miles across and 1,000 miles long.
Where do they typically occur?
We have learned the most about them on the U.S. West Coast, but they're a phenomena that spans the globe.
The term atmospheric river, has that been around for a long time, or is it just gaining momentum now?
It emerged in the early 90s in a series of 4 or 5 papers that were published in formal journals, but it wasn't until 2003 that I noticed the AR paper that the light bulb went off. I'm like, oh, that's exactly what we're studying. And it became obvious at that point to me that this was a super important phenomenon and that we could then formulate studies and data collection and modeling to better understand them. It was super obvious from the very beginning that they were the real rainmakers on the West Coast.
Does El Nino or La Nina impact atmospheric rivers?
Interestingly, that's been a very common perception, but it's remarkable that we really haven't been able to show that. In the last 20 years, there have been, say, 4 El Ninos and 4 La Ninas. The La Ninas have been unusually wet in Southern California, which is usually, when we expect dry. And the El Ninos have been sort of ho-hum or even a bit on the dry side. And when you look back at the count of ARs that hit Southern California, that basically explains the difference.
Are you ever going to start naming them?
That's come up many times, but there are too many ARs each year. If you add up the entire West Coast, there might be 50 of them in one year. So it's a little bit, I think, logistically not feasible to name names, and it would get super confusing.